Hi everyone, welcome to today's session. Today I am gonna discuss about a organic name reaction. So this Bamford-Stevens reaction first had proposed by two scientists, William Randall Bamford and Thomas Stevens, in 1900 to 2000. According to them, this reaction, the tosyl hydrogen or p-toluene sulfonyl hydrogen of aliphatic aldehyde or ketones furnish more substituted alkenes when treated with a strong bases like sodium ethoxide, sodium hydride or lithium hydride or sodium amide. But there is a similarity in mechanism for this Bamford-Stevens reaction and Shapiro reaction. Both the reaction afford alkenes from tosyl hydrogen. In case of Bamford-Stevens reaction, the more substituted alkene is formed as the thermodynamic product, whereas in Shapiro reaction, the less substituted alkene is formed as the kinetic product. This reaction employs bases such as alkyl lithium and Grignard reagent. So this synthetic path for this Bamford-Stevens reaction involving sodium methoxide as a base and giving us a olefinic product where two double bond is forming is substitution is more. So this is giving us a olefinic product. So I'll come to the mechanism part for this Bamford-Stevens reaction. So the mechanism for this reaction is goes through two steps. In step 1, the sodium ethoxide will give Na plus and MEO minus. So this MEO minus will attack in step 1. It will, suppose this is our, according to our reaction, this is our reactant. So this MEO, this one will take up this hydrogen, so that this one will form a anion on nitrogen, which will give us like this kind of product. So this lone pair of nitrogen will migrate towards to the next bond, so that this tosyl group will go out and it will give us the corresponding product. So this is the entire step 1. Now I'll come to the step 2. So this reaction may be preferred either in protic solvent like a glycol or in aprotic solvents like ethylene glycol, dimethyl ether. So first this product will take with protic solvent. Protic solvent means which can transfer hydrogen atom easily. So with protic solvent, mechanism will happen in one way, and with aprotic solvent mechanism will take place, but in both step, in both method, product will get same, olefinic product will get, but that mechanism, way of mechanism that is different. So with protic solvent, reaction will take place like this. So here is a double bond, how it was before, same thing I am writing. Then with protic solvent means, suppose S is the any substitutional group which has one hydrogen atom. this bond will form a bond with this bond will come, and in this from the central carbon atom it will form a bond with the hydrogen, so that S will eliminate from here. It will give us this corresponding product with forming a bond with hydrogen, and here is a N triple bond N, so that this N will get one positive charge, so that in later this will go out as form of N2. This one will go out as a form of N2, so that it will give us in this carbon it will come a positive charge. So in last step we will get olefiny product, but it will give two types of product, two types of enantiomer product, E and Z, depending upon what kind of reactant is involving in reaction, whether it will give E is to Z product, which one will give major product, it depend upon the what kind of reactant and reagent is involving. So this is our required product. Along with that, other enantiomer also, that isomeric product that also I am writing. So here R1 and R2 was cis, but here in this case R1 and R3 was cis, and along with that this S and H, that solvent, it will come. So this is our product. So this one we did with protic solvent. Now I'll come to with that another mechanism path, how it is happening with aprotic solvent, that one we'll discuss. So this step 2, same step 2 we'll discuss with aprotic. This is with protic solvent. This one we'll discuss with aprotic solvent. In this aprotic solvent we'll take R2 with R3, so this bond will migrate towards to this side, and this negative charge will come to this side. It will form one new bond in between nitrogen to nitrogen atom, will give us three bond will form in between two nitrogen, which in this nitrogen will get one positive charge, and in this carbon one positive charge will come on the carbon. It will eliminate from here in form of N2, will give us, which will give us this product. Because of two nitrogens are coming, this it is lacking of valency in this carbon, so it will form a carbon ion free radical. So in next step, by 1 to hydrogen shift, this hydrogen will shift. So according to them, its name it is 1 to hydrogen shift, from one position to second position is shifting. So 1 to hydride shift it will give us our required product. We'll get our olefinic product. So this is one kind of enantiomer. Along with that, other possibility also, other possible structure also. Along with this, two kind of structure will get. Among these two product, one should be the major product. So this is the mechanism part. Now I'll discuss some of example. Some of the example which may help for understanding how these reactions are taking place, and different reagents are also involving in different kinds of example. In first example, toluene, this is the thermal Bamford-Stevens reaction, where toluene under 145 degrees Celsius temperature reaction is taking place in a sealed tube, which is giving us E/Z ratio in 90:10. So E isomer is giving the major product. In the second example, here is a cyclic ring is present, which has one methyl group, substituted methyl group is present. Along with that, tosyl hydrogen is there. Sodium methoxide is involving as a base, and glycol at 180 degrees Celsius temperature it is giving us a product where this alkene double bond is forming inside this cyclic ring, because these two carbon, in this carbon methyl group is present. So according to the statement of this reaction, it should give us a substituted alkene. That alkene bond, the double bond will form where more substitution is present. So here methyl group is present, so it is giving here double bond is forming. So in the another example, in the last example, here potassium betoxide and butanol in reflux condition, which is giving us a following this kind of required product. This it is forming in this side chain reaction. In side chain it is forming a O-butoxide, and olefin, how it was before in reactant side, the double bond is present inside the ring. So if I'll come to the application part of this reaction, so this reaction in industry, in research area, this reaction is mostly used for the preparation of diazo compounds. Other than this, because of its more usefulness for this reaction, it is involved in different area. So these are the entire discussion on Bamford-Stevens reaction. So thank you so much for watching this video. Please subscribe this channel so that you will be in touch for next video. Thank you.